I'm Clive Cook, CEO and co-founder of Precursor SPC. There is an urgent and imminent, potentially catastrophic seismic threat facing many regions of the world. I live on the US West Coast. We're all waiting for the next big one. Despite opinions that nothing can be done, Precursor has a proven solution to prepare for these threats by forecasting the location, magnitude, and time days before a seismic event. Next slide, please. Earthquakes are the costliest and deadliest recurring natural disaster. On a human time scale, months, weeks, days, earthquakes are unforewarned seismic events. Existing solutions provide 20, 10, 25, and 100-year predictions, or a shake warning 30 to 90 seconds after the quake if you're 20 miles away. Neither of these are actionable. Next slide, please. Precursor has taken a novel approach to geospatial event risk, both earthquake risk and space weather event risk, by first defining the problem differently. Precursor is solving the problem of no actionable information prior to a seismic event or earthquake. Addressing this challenge, Precursor has a unique, comprehensive understanding of the established science that causes time-based earthquake phenomena called earthquake precursors. And then Precursor puts in place a dual-use industrial IoT network of advanced specialized ground sensors and space-based systems, gathering proprietary data sets and using ALML techniques to accomplish forecasting. Next slide, please. Precursor has forecast over 50 seismic events in 5 countries with compelling results. Each pilot program took place over a 12 or 18-month period during which Precursor first baselined the pre-earthquake conditions in specific locations around the world, and then used this knowledge to identify the buildup and changes in energy that always precede an earthquake. The results of these programs showed definitively the ability to forecast the location, magnitude, and time days in advance of the seismic event. The results of these programs provided actionable information. Next, please. Actionable geospatial event information enables accurate forecasting, timely preparedness, and management of short and long-term risks. Initial demand for Precursor's data subscription services will come from private and government large asset owners, commercial, government, and defense organizations, and reinsurers and derivative financial markets covering extraordinary loss. Today, in countries and businesses with industrial infrastructure, old and new, electric grids, pipelines, high performance data communication systems, refineries, chemical plants, warning systems of critical events have often not been built in place, nor have these events been integrated into critical operations. In cities seeking to modernize their infrastructure, many are integrating at the time of construction or retrofitting directly into their smart cities initiatives, advanced warning for both earthquakes in seismically active regions and space weather events. Next slide, please. Precursor has built considerable traction since its early beginnings. We've raised a $2 million convertible round, and we are currently raising a seed equity round. We've successfully completed a number of earthquake forecasting programs and have demonstrated our space weather nowcasting capability for the US military. We have a number of established partnerships with US government agencies, technical partners, and a number of MOUs with commercial reinsurance firms. We're finalizing initiatives in the US, Europe, and the Caribbean for both our earthquake forecasting capability and our space weather nowcasting capability. Next slide, please. Precursor is seeking $5 million in a series seed equity round to advance the company to its next milestone and begin the commercial launch of our data subscription services. Thank you for your time.
Wonderful. Thank you so much. I bet everybody here is a little bit surprised to know that you could know about an earthquake a couple weeks ahead. Pretty crazy. Susan, do you want to start with the first question?
Yeah, I'm happy to. Thanks so much, Josh and Clive. Thanks so much for that presentation. Suzanne Fletcher with Prime Movers Lab. Very curious, Clive, how you think about the sizing of the market, both on the government and then the private side. I saw your calculation in terms of the losses that folks suffer, but how do you think about the relative kind of TAM here?
The TAM, because the capabilities we're giving are unique and first of a kind, the market spaces that we're operating in, we think are analogous first to weather and weather forecasting systems. So as an example, in the US alone, weather forecasting and weather forecasting services are a $15 billion annual industry. Earthquake forecasting we see in the future as being analogous to that and providing equivalent capabilities and services to the private sector, to governments, and so on. So that we certainly think that's a plus $10 billion opportunity. In addition to that, there are a number of opportunities, as I mentioned earlier, in the financial services industry, specifically in insurance and reinsurance, where they are looking to have this capability to both provide an assessment of risk for their policyholders, and then in the reinsurance world, where they are acting as both the insurer of last resort, as well as providing something called insurance-linked securities, which is a very vibrant marketplace for that financial services. You know, that's just a massive market, and we see that as a $5 to $10 billion opportunity for each of all of those capabilities. Sorry about my dog in the background. And then lastly, for the space weather forecasting capability, as the space sector is evolving right now and growing dramatically, commercial satellite operators, private companies that are operating in space, and government organizations that are operating in space need to understand the space environment for their operations and their space situational awareness. In that arena, we think is growing from something around a couple $2 billion today to be at least a $10 billion market going forward. So we think that it's quite a large and diverse market opportunity, TAM, across there. I'm going to go mute just because my dog is going crazy. Sorry.
I think I have a next question. I think it's always very powerful, right? If you have a crystal ball to predict the future, but it's also sort of a two-edged sword. Like, what if it's not accurate, right? Then the customer may suffer consequences as well. So based on what you have today, you said 6 pilots predicting 50 plus seismic events. Is that something like, 50% accuracy, 60%, or is it like 90+% right now?
Our approach does not use a crystal ball or anything like that. This is a data-driven approach, which gathers unique, measurable phenomenon in real time and uses that to accurately determine the magnitude, the location, and time of seismic events as well as space weather events before they happen. In the programs that we've done, both in terms of the 50 seismic events that we forecasted, as well as the space weather events, our accuracy is well over 90%.
Great. And that means that it's based on the sensor, IoT sensor you mentioned that you have to put under or the surface. And with one sensor, what is the amount of coverage, the miles radius that it can report?
We take advantage of 2 key elements in our IoT network. One is a ground-based multi-sensor station, consists of 5 to 12 different sensors that cover a radius of 50 kilometers. And those are put down in a hive configuration around cities, around power plants, around industrial structures are important. And then over top of that, we use multiple satellite-based systems, both private and public systems to augment the coverage from the ground-based systems. And that gives us a very wide coverage at very minimal cost with very, very high accuracy and efficacy.
Thank you.
Question, Clive. Thank you. Kenny Basai from Google. I didn't see in your partnership mention of USGS. Have you compared your measurements to how USGS collects data and their accuracy?
USGS does not forecast earthquakes. USGS, what it does is provide 25, 50, and 100-year predictions of earthquakes. And it provides what's called a shake warning system 30 to 90 seconds after the quake. They are very, very strong in seismology, and seismology is the measurement of mechanical events, rock rupture and movement. And those events happen over, as I mentioned, 25, 50, 100-year timeframes. Their expertise and their capabilities are not, quite frankly, are not the same as ours. So that's why we are working specifically with various US government agencies to provide this capability, because it brings together a multidisciplinary capability, satellite-based systems, machine learning-based systems and analytics, as well as measuring the electromagnetic phenomenon that always precedes these geospatial events. Those three capabilities are not in the mandate, nor are they in the suitcase of skills that USGS has. So we're very different organizations focusing on very different outcomes and analyses.
And one more question about your space weather. That's a different use case, right? If you have sensors on satellites,
it's the same IoT network. It's just it is a different algorithm. It's a different machine learning algorithm, but it's the same sensors and the same satellite systems. It's a dual use IoT system.
Yeah, thank you.
I have a quick question, Clive, regarding some of the topics you just spoke on. For example, I guess the main question is, how are you training? What are the machine learning algorithms trained on? And a little bit to what you were speaking on with the seismology, it makes sense what you just explained. I was initially expecting to see some seismologists on your team, for example, to have that insight, and maybe a bunch of really hardcore machine learning people. I didn't see the team slide very long, so perhaps there already are.
Actually, a couple things. So we have one of the world experts in geophysics, Dr. Pierre Richard Corneli. He's an expert in geophysics and atmospheric physics with a strong background in data analytics. Then Dr. Wilfred LeBlanc is one of the world recognized experts in AI system development, specifically code-excited linear prediction models. And then my background is in high performance machine learning algorithms as well. So we have a very deep background in specifically in machine learning, time-based machine learning. And then we have, as I mentioned, a strong capability in geophysics, not seismology. We're not using the seismic history as a measure of the next earthquake, because it doesn't tell you anything about when the next earthquake is coming. It just tells you that you've had an earthquake and you can attach that to some distribution, and maybe in 25 years or 100 years it'll happen again, but it's not particularly actionable.